So here we have a disabled automobile that is pulled by two ropes. One is rope AB, which has a force of 3 kilonewtons, and another one TAC, with an angle of alpha. The resultant force will be, let's say, R, and equals to 5.4 kilonewtons. And we need to find force AC and the angle alpha. To start with this problem, we should always draw an FBD real quick. So here we have point A and a force TAB, a force TAC, which one has 30-degree angle and alpha. And the resultant force, we have R pointing in positive x direction with a magnitude of 5.4 kilonewtons. By looking at the FBDs, we can see that it is actually a a vector addition. So we have force TAB, and we can move TAC to here with a resultant force of R. So here is 30 degree, and here we have alpha. So first, we want to find TAC. By solving this triangle, we can use law of cosines, which TAC equals square root TAB squared plus R squared minus 2 TAB times R times cosine 30 degree. Just to recall the law of cosine, so C equals square root A squared plus B squared minus 2AB cosine delta, which here we have side A, side B, and side C, and here's delta. All right, and going back to the question, we can just plug in the number. TAC equals square root. Here TAB we have 3 kilonewtons, and R is 5.4 kilonewtons. And by solving that, we have TAC equals 3.36 kilonewton. And move on to solving alpha. We can use law of sines. Here, sine alpha over TAB equals sine 30 degrees over TAC. And we're plugging TAB and TAC. We have sine alpha equals, just moving sine alpha on y side. So we have TAB sine 30 degree over TAC. And by solving that, we have alpha equals sine inverse TAB sine 30 degrees over TAC and again TAB is 3 kilonewtons and sine 30 degrees, and we have TAC equals to 3.36. And now we can solve for alpha, which is 26.6 degree. So alpha equals to 26.6 degree. So when we look back into the problems they give us, TAC, we have 3.36 kilonewtons, and alpha is 26.6 degree. So when we having these two ropes pulled together, we can see that in y direction, both rope cancels out their force in y direction, and add their x component force up and have a resultant force of 5.4 kilonewton. So as a result, the car will move along the positive x directions. Yep, so this is homework 1, problem number 1. If you have any questions, feel free to join in the office hours, and hope to see you there.